Good morning, students. You're all welcome to this map reading and interpretation class. This class is exclusively for SS3 students who are preparing for WAEC and NECO exams. Our topic today is map interpretation, but our lesson is specifically on map reduction and enlargement. What is our specific objectives for this lesson? What do I intend students to learn, to know and understand by the end of this lesson? By the end of this lesson, the students should be able to, 1, measure the size of a map, enlarge and reduce the size of a map, give precise interpretation to a geographical portion of a map sheet. Enlargement of map. This area has been an area that gives students troubles. They are always afraid of seeing the large size of topographical sheets offered to them in the exam hall. And it has reduced students' participation in the subject of geography. But I want to encourage you, and I want to make this lesson as simple as you would understand, that every fear will be erased from your mind, in respect of seeing a big topographical sheet that is placed before you. The only thing you just have to help me do is to be attentive and listen to the instruction as it comes out. Enlargement of map. To enlarge a map is simply to increase the size of the map. I repeat again. To enlarge a map is simply to increase the size of the map or a portion on a map sheet or a portion on a plan given to you. And also most of you will soon grow up, graduate into being civil engineers, surveyors, architects. You will be using these principles subsequently. As you progress, listen and be blessed. For example, if the scale of a map is given as 1:50,000. Given that the scale be enlarged to twice the original size, you will proceed as follows. Step 1. Measure the length and width of the original map using a ruler. Step 2. Double the size of the map. That is original length and width of the map. Step 3. Divide the scale of the map by 2. I will tell you why you will divide it by 2, not multiplying by 2 in this regards, because that is a question most students used to ask. Why are you dividing it by 2? Or are you dividing it by the number of times you are asked to enlarge the map? or to enlarge a portion of the map. Please, we will get to know that later, but let's proceed. It is important to note that when you reproduce a map, enlarge or reduction, one, it will give the new edition of the map proper labeling. Two, this labeling includes title, compass direction, scale of the map, outline of the map, key stroke legend. Just as you know. We are going further to do some practical exercise. Listen and be blessed. Example 1. Enlarge the square below by 2 times of its original size when the scale is 1:100. I read the question again. Enlarge the square below by 2 times of its original size when the scale is 1:100,000. Now, if you look on the board there, you will see the old scale, 5 cm width, 5 cm length. The width is the horizontal line and the height is the vertical line. You can also say that the next portion is gridded. You all know what grid means. The small squares, the vertical lines and the horizontal lines that crisscross the surfaces of the map is called grid lines. You all know that. Now, solution. Old length equals to 5 cm. Old width equals to 5 cm. Scale of the original map equals to 1:100,000. Number of times the original map is to be increased is 2. In this case, you are given exactly the number of times the map is to be enlarged. As you progress further into this lesson, such specification may disappear. But it is up to you to use the minor formulas you will be given to solve this particular problem. If you look at the next box below the first one, you will now see the result of the old length, which is calculated 5 times 2 is equals to 10. 5 times 2 equals to 10 cm. So the new scale will now be 1:100,000 all over 2. 1:100,000 all over what? 2. Now, if you divide that, you discover that the answer you are going to get will be 1:50,000. 1:50,000. Now, look at the gridded box beside the enlarged map box. Now, why is it gridded? Or how is it gridded? Let me explain to you. The length, the old length is now 10 cm, and the new length, the new width is now what? 10 cm. All you need to do, simple analysis. Divide this 10 by 2. And if you divide this 10 by 2, what will you get? If you divide 10, or if you allow 10 to go in 2, it will go into 10, 10. How many will you get? You have 5. You have what? 5. 5 can go into 10, successfully 5. Now, the squares below, in the box, that means you have 2 cm. So each of the small squares in the box will be what? 2 cm. Why is this necessary? It is necessary that because you might be asked by an examiner to probably insert a major road or a minor road, to insert a river, to insert an island somewhere. In that geographical portion, you are to enlarge. So you take critical note of these little things. It will help you. In map enlargement, you understand our explanation that you multiply the length, the old length, by the number of times you are asked to enlarge the map. You multiply the old width by the number of times you are asked to enlarge the map. So the new scale you are given is a new drawing you are going to make. And I told you earlier before this time that labeling is very compulsory. The map must have a title. The measurement you have obtained must be fixed on the portion drawn, and you label the map accordingly. The compass direction, you must state it, because in some cases you might be asked to determine the flow of a river. And without the showing of this cardinal direction, this compass bearing, you might have problem in understanding where the river is emptying itself, what is emptying itself into, or where the river is flowing to. So you must take cognizance of these little facts. Okay, as we progress in the lesson right now, we move down now to map reduction. Map reduction. What is map reduction? Just as the name implies, you are reducing a given size of a map. Or you might be asked to reduce a given portion on a map sheet. You are all aware that if I request that you draw the size of this classroom on paper for me, I don't see any company that may have manufactured the kind of paper that can say take the size of this classroom for you. Invariably, it is impossible to put this classroom exactly as it is on paper. But geographers have devised a simple means to help solve this problem. That whatever that is on ground can be represented on paper. That is the reason for map reduction. In your exam, as it is coming, definitely you must be asked to reduce certain given portion of a map. Or you might be asked to reduce the map sheet that is given to you. As you often see in WAEC, in NEPCO, and in GCE. So to reduce a map is to shorten the size of the map. I repeat again, I said to reduce a map is to shorten the size of the map. E.g., if a map scale is given as 1:50,000 and you are required to reduce it by half of its size, you will proceed as follows. Just like in the case of map enlargement, it is the opposite of the enlargement that gives birth to what? Reduction. 1. Measure the size of the map using a ruler. That is, you measure the width of the map as it is seen. You use your ruler. You get your point A, you get your point B, you get your point C, and you get your point what? D. You measure your A to B, and you measure your A to D. You now have the length, the width, and you now have what? The length of the map. That's now from what we call old length and old what? Width. You now multiply the scale by the number of times you are asked to reduce this map. I told you I will explain that to you. You know, in the case of multiplication, in the case of enlargement, we divide the scale. But in the case of reduction, you multiply the scale. Now, let's come in now. You know, when you are enlarging something, you have little features that will be represented in it, but you are covering a very large expanse of space. Because little explanation or fewer items is found in an enlarged area. It's just like a classroom, where the classroom initially was taking about 40 seats for pupils, and suddenly that a renovation work came in, and that class was doubled its size. If it was taking 40 seats before, and the class is doubled its size, what do you think will happen? And using the same quantity of seat that was in the class, you see that the seat will be evenly spaced. This other portion will take 20, and this other portion will take 20. And even the 20 that you see in the class will be well spaced. So before you will count 1 there, 2 here, 3 here, 4 here. But like before, it was 1, 2, 3, 4. Like that, in that progression. So you see, in map enlargement, the scale of the map is what? Reduced. A map that was to a scale 1:100,000. By the time it is enlarged, you have 1:what? Depending on the times you are asked to enlarge the map, will be 1:what? 50,000. 1:25,000, as the case may be. But in the case of reduction, you are compressing things together. You are compressing structures. You are compressing features together in a very small place. Which means that You are telling your reader, for every 1 centimeter you see on this paper may represent 200 kilometers on ground. Can you imagine that? You are multiplying it. Even though on paper the structure the portion is compressed, but there are several things, several details that compressed portion will give to you with proper interpretation. Except with larger scale, you cannot interpret, and you cannot give good presentation to the features compressed on the plan. So what we must do at this point is that you measure the size of the map using a ruler, as I've told you, reduce the size of the map by half, multiply the scale by the number of times you are asked to reduce the map. Let's take this example. Given that the scale of the outline of a map is 1:50,000, reduce the map by half of its original size when the length and width are 8 cm respectively. So you understand the question there? A question there is saying that the original scale of the map is 1:50,000 and the original length of the map and width of the map are 8 cm respectively. My students, it is simple. All you need to do is to put your ruler on paper. Your A to B, 8 cm. You rule. Your A to C, 8 cm. You rule and you join the squares. You join the square together. That gives you 8 cm by 8 cm what? Box. It is simple. Like the explanation I gave to you before. As you draw this little box of 8 cm by 8 cm, sometimes you don't leave it plain. You use that exact system that was done in the case of enlargement to grid the surface of it. That will help you for place location. The vertical and the horizontal lines. You know, we use latitude and longitude for place location. Simple. So if you're asked to insert any features, it will help you. You know exactly where it is found in the map, and that is exactly where it will be on the paper. So let's follow this exercise. Old length is equals to 8 centimeter. Old width is equals to 8 centimeter. Scale of the original map is what? 1:50,000. Number of times the original map is to be increased is by 2. That is 2 times. Now let's have a new length. The new length will now be 8 times 1/2. New width 8. You can say multiply, or you say divide 8 by 1/2. That gives us 4 cm respectively. 4 cm respectively. So the box you are going to draw on paper has reduced from the 8 cm to 4 cm respectively. The new map scale. We said in reduction you multiply the scale. So what you have to do is to multiply 50,000 by 2. What do we have? 100,000. So for every 1 centimeter you see on the ground, we'll explain a detail of 1:100,000 on ground. That is, for every 1 centimeter on paper represent 100,000 centimeter Is that understood? So the new box we are going to have will be 4 cm by 4 cm respectively. You do proper labeling as you were told. Put your scale below the map. Put your title. You put your direction. And you grid it. It is simple. The problem is solved. We take the second exercise. If a map with a scale of 1:50,000 is to be drawn on a scale of 1:200,000, what is the degree of reduction? I repeat again. If a map with a scale of 1:50,000 is to be drawn on a scale of 1:200,000, what is the degree of reduction? The degree of reduction is very simple. Questions like this are often presented to students in their WAEC, NECO, and GCE. And sometimes you begin to look left and right. What is the solution to this kind of problem? It's simple. Don't just confuse yourself. What is the solution to the problem? First, you determine the degree of reduction. First, you determine the degree of what? Reduction. And what is the formula for that? Old scale all over new what? Scale. So if we have old scale as 1:50,000 and new scale is 1:200,000. So you just simply say 1:50,000 all over what? 1:200,000. That is equals to 1/4. That means you are asked to reduce a given portion by 4 from its original what? Size. Are you confused? Let me come again. Old scale all over what? New scale. All of you are mathematicians. When you determine this, you do your simple calculation. Like the example presented here, it is 1/4. 1/4. That means you are asked to reduce a given portion or a given plan 4 times from its original what? Size. That is simple for you. 2. Draw an outline of Sabongida district on a scale of 1:200,000. And on your outline map, draw and name the minor road. Name the minor road. Draw an outline of Sabongida district on a scale of 1:200,000. And on your outline map, draw and name the minor what? Road. Now, in this case, you discover that the new scale is not given to you. The new scale is not given. But you are working with the old scale, which is 1:200,000. Now, a map sheet has been given to you. What is that map sheet drawn on? What is the scale on which that map sheet is drawn? That is the simple thing we are asking from you. So it is still the same procedure. New scale all over what? Old scale. For instance, the new scale of the map is 1:50,000. And this one that we have here is 1:200,000. What is it? It's just to divide them. When you do your division, you now know the number of times you are asked to reduce a given portion of a map. Okay, let us be more practical. the dimension of the original map, that is the map before you, is 1:50,000. The width of the original map is 36.5 cm. Length of the original map is 36.8 cm. Dimension of new outline map, new scale, that is scale of the outline map, equals to 1:200,000. That is our original example, the question, 1/200,000. We have looked at the degree of reduction, and the degree of reduction says old scale over new scale, which is 150,000 all over 1:200,000, which is 4 times 1/4. And if it is 1/4, you look at your new drawing there. You now say width of the outline map is 36.6 times 4 divided by 4. Length of the outline map 36.8 divided by 4, or times 1/4. Now it gives you 9.15 cm, 9.2 cm respectively. By that measurement, you use your ruler and get your measurement on the new plan, and you just do it briefly. Note that the width 9.15 cm is the horizontal line. Length 9.2 cm is the vertical line. Let us have a recap of what we have done so far before we come to the end of the first phase of this lesson: map reduction and enlargement. I told you specifically that a map enlargement, having followed all other procedures, that the scale in multiplication, the scale is divided. You divide the scale by the number of times you are asked to enlarge the map. I have given you the reasons for that. When few persons are in the house, and the house has a bigger space, what do you think will happen? When they are going to bed, people will just lie at any corner of the house. And if you are asked to take the statistics of the house, of the people in the house, you will say 1 is there, 2, 3, and 4. So you see, little explanation is given to a larger space than it is given to a compact one. So as we have explained to you, that the map enlargement, the scale is what? Reduced. But in map reduction, the scale is basically multiplied. Because you are now coming to study so many things that are in a compact area, and you give precise details to these compact features you have seen. I think with this explanation, we have done some level of justice to the study of map reduction and enlargement. I think as you go into your exams, it will be easier for you to apply this principle to solving problems that will be given to you, because I know that WAEC, NECO in your GCE, out of these three examples I have presented to you this evening, they will not escape one. Most often these days, what we see is that of mark reduction. Either you reduce a portion for the sheet that is given to you. Thank you, and God bless.